Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 1A Part 2 assignment from Core Topics. Okay, so first one we're going to look at here is 15A. Find in gradient intercept form the equation of the line which passes through this here. So probably can just use the slope formula, right, which is y2 minus y1 over x2 minus x1. That'll give us a slope, and then we can use either one of the points to plug into the point slope formula, which, if you'll remember, is y minus y1 equals m times x minus x1. Okay. Now, for slope here, actually, my algebra teacher taught me this little trick here. I always just do this. I don't even set up the equation. I just do 11 minus 1 over 3 minus negative 2. The biggest thing that gets messed up with on slope is forgetting this negative here, because it's subtract, so you got the minus a negative, so that turns into a plus. So that gives us 10 over 5, which is 2 for our slope, right? So now we can take that, plug it in here for our slope, and then we can choose either point here. I'm going to choose this one because the numbers are a little bit smaller. So we got x minus negative 2. And we got y minus 1. So we got, and then we just simplify this. Equals 2x. This turns into a plus. 2 times 2 is 4. So we add 1 to both sides, and we get y equals 2x plus 5 would be our equation in gradient intercept form. Okay? All right, next one, 16. Find in general form the equation of each line. So this is a line here, but the thing is it gives us 2 points, so it's just like what we did on 15 and just use the two points here. So we got negative 3, negative 4, and 2, 6. So I'm going to do 6 minus negative 4 over 2 minus negative 3. And you could have put 2, 6, and negative 3 minus 4 and still done it the same direction, and it's going to end up working out. You'll just end up with 2 negatives instead of 2 positives, but a negative divided by a negative is still a positive. So this gives us 10/5, which is 2 for our slope, right? So then we got, plug that into point, let's see, general form. I'm still going to plug this into the point slope formula so that we can get it into y equals, and then we can just move everything over. I find that that's, at least for me, that's probably the easiest way to do it. So y minus y1 equals m times x minus x1. So y minus, and we can choose either one of these. Let's choose, I'm going to choose this one because it's got a couple of positives. Y minus 6 equals our slope, which we just found is 2, and then x minus 2. So y minus 6 equals 2x minus 4. Add 6 to both sides. Y equals 2x plus 2. But now it says general form, the equation of each line. So now we have to move this 2x back over. Okay, so subtract 2x from both sides. We get negative 2x plus y equals 2 here. And also the other thing with general form is this always has to be a positive to start with. So we basically want to multiply everything here by a negative 1, which, or just a simple way is just switching all the signs. So we get 2x minus y equals negative 2 is our answer in general form. Okay. 18, find the equation of the line which is perpendicular to this and passes through this point. So perpendicular, if it's parallel, it's this exact slope. If it's perpendicular, you'll remember we got to do the inverse reciprocal, which is flip it and switch it, right? So right now it's negative 2 over 1. So perpendicular means that that's going to turn into, the 1 goes on the top, the 2 goes on the bottom, and it changes from positive to negative. So our perpendicular slope is 1/2. So now we can plug that into our point slope formula, right? So we get y minus 5 equals our slope, which we just figured out since it's perpendicular has to be 1/2, and then x minus negative 1. So y minus 5 equals 1/2 x plus 1/2. And we add 5 to both sides. And we get y equals 1/2 x plus 5 and a half. And let's see, it says find the equation of the line. It doesn't say it had to be in point slope or general equation. So we'll just do, I'm going to go with point slope here. Okay. All right, next one here is 19. Determine whether this point here lies on the line that has this equation here. Now, just to figure out if this lies on this line at all we got to do is plug our -4 in for x and our -8 in for y and see if this is true. So we just do 7 times -4 minus 3 times -8 and see if that equals -4. So that's -28 plus 3 times 8 is 32. Right, and that's positive 32. So let's see, that's -28 plus 32 is 4, does not equal -4. So it is not on the line. So this point does not lie on the line that has that equation. Of course, now looking back at this, -3 times -4 times 8 would be positive 32, but it's -3 times 8, so that's plus 24. -28 plus 24 is -4, so -4 does in fact equal -4, so it is on the line. So my apologies for my math error. Okay, here we go. 21. Find k, given that k 0 lies on the line with equation 3x minus 4y plus 36 equals 0. So here's what we want to do. This is our x value. This is our y value. Let's just plug these in and see what we get. 3 times x, which we now know is k, minus 4 times y, which we now know is 0, plus 36 should equal 0. So 3k minus 4 times 0 is 0, plus 36 equals 0. So subtract 36 from both sides. 3k equals -36. Divide both sides by 3, and we get that k has to equal -12. Okay? All right, that's all there is for this section. If you have any further questions on this, please feel free to ask. Thanks.